Section 5, Unit 1, Introduction to the Lathe. The lathe holds and rotates the workpiece against a cutting tool. Cutting tools are guided along a part to remove material, producing cylindrical parts. Major components are the bed, the headstock, the tailstock, and the carriage. The lathe holds and rotates work against the cutting tool to machine with cylindrical components. Movement of the cutting tool determines the shape of the cylindrical part. Headstock contains the spindle, which holds and rotates the workpiece. Work holding device attached to the spindle nose. They're driven by a motor through pulleys on a belt drive lathe or gears on a gearhead lathe. Contains a gear train, quickly change gearbox, which controls the rate and tool movement or feed, and located in the upper left side of the lathe. Here are some examples of components for machined on a lathe. The headstock of a lathe contains spindle and the belts or gears that power the spindle to transmit power to move the cutting tool. A lathe spindle holds and rotates work for machining. Its hollow construction allows long workpieces to be placed through it. The tapered front section aligns and secures accessories that can be removed with a knockout bar. So on the left it's showing you got a dead center on there, whereas the right you got a chuck on there. Spindle noses. The spindle nose is used to mount work holding attachments. A threaded spindle nose is shown, but it is not very common in lathes today. Never attempt to mount a work holding device to a threaded spindle nose by running the spindle under power and holding the chuck. Always thread it on by hand with the machine power off. Caution, work holding devices can unscrew if the thread lathe spindle is run in reverse. A tapered spindle nose, sometimes called an L taper. So you have a key in those. A cam lock spindle nose and some mating work holding devices. That's probably the most common use today. Setting spindle RPM on a belt driven lathe is done by placing a belt in different positions on a step cone pulley in the lathe's headstock. Setting spindle RPM on a belt driven lathe is done by placing a belt in different positions on a step cone pulley on a lathe's headstock, as we just said. The quick change gearbox changes the amount of feed per revolution by changing lever positions. Alright, then you got your lathe bed, foundation of the machine, seen on the right side of the headstock. Top of bed contains precision ground flat and V-shaped rails called ways. The bed is the foundation of the lathe. The ways are precision ground rails that are usually flame hardened for durability. Do not lay tools on the ways or excessive wear and damage may result. There you got the carriage. The carriage supports cutting tools and slides along the bed ways. The saddle is the H-shaped slides on the ways. Supports cross slide and compound rest. The apron hangs from the front of the saddle, contains longitudinal hand wheel and feed controls that move carriage or cross slide. You got the lead screw, transmits motion to carriage for thread cutting operations. The feed rod transmits power to apron gear train for feed motion. The carriage supports cutting tools and moves along the ways to provide tool movement. The top section that rests on the ways is the saddle. The apron is suspended from the saddle and hangs down in front of the bed. So your saddle is here and your saddle motion is going to be this way. The cross slide provides tool movement perpendicular to the ways. A graduated micrometer dial on the hand wheel allows precision movements to be made. So there's your cross slide, it's going to be like this. And there's your micrometer collar. The compound rest can be adjusted at any angle and is used for tool movement other than longitudinal and cross feed. So there's your clamping screws, your angular scale, your compound rest itself, the compound rest hand wheel, and the micrometer collar. Adjusting the gib on the compound rest tightens the dovetail slide and reduces sloppiness caused by wear. The feed rack, lead screw, feed rod, and spindle clutch lever. So feed rack, lead screw, feed rod, and spindle clutch lever. Alright, then you got your apron hand wheel, your feed change knob, your feed reverse knob, your half nut lever, and your spindle clutch lever. You got your thread dial and your feed control clutch. Then you got your tailstock. The tailstock can secure work holding devices for supporting long workpieces, mount and guide cutting tools such as drills, reamers, countersinks, etc. Slides on ways like carriage but lock into place during use. So, of course, you got the quill locking lever. You got this tailstock locking lever, which allows it not to move at all. This just tightens this where you can't move it. Your hand wheel moves the whole quill in and out. Your micrometer collar shows you how much you moved it, and your adjusting screw to move it left and right to get it on center. Lathe size, specified by swing, bed length, and maximum workpiece length. Your swing is determined by biggest diameter workpiece mounted in the spindle. Your bed length is measured from headstock to the end of the bed, and your maximum workpiece length is determined by the distance between centers. So, A is your bed length, B is your distance between centers, C is your swing, and D is your swing over carriage. The same lathe with a gap removed to allow machining of diameters larger than the swing. And a lathe with a removable gap, notice the split line at the feed rack of the bed below the ways. So you can actually take this first piece out just so you can get a bigger part in there.